The Labbit project kit from Kitronik has a collection of sensors and controllable devices conveniently mounted on a single board. Used with the Mr. Bit Plain English coding editor, it is easy to explore how the BBC microbit can become an intelligent control machine. Here is an example. Two crocodile clips are attached to make a simple input switch. With nothing touching them, the switch is open, and the microbit LEDs show a cross. However, when a good electrical conductor touches both clips, the cross changes to a smiley image. Thus, metal objects are detected as good conductors, whereas materials such as plastic or paper are confirmed as insulators. The program that controls the microbit is here. Insight Mr. Bit uses color-coded boxes to represent inputs and outputs like this: blue input, pink output. The green control module contains the program in which the input controls the output. The program script is shown in the top panel. To see the program working, we shall add the video of the microbit and also show the Mr. Bit simulation of the Labbit. Let's go. Notice how the coins change the input signal which shows in the switch block. The program script responds accordingly with two instructions following each other. Each instruction controls the microbit LEDs and says exactly what happens when the switch is open or closed. Here's another example. This time the input is the microbit's movement sensor, and the output is a set of LEDs arranged like the face of a die. Each time the microbit is shaken, the shake control generates a new random number, and the display control selects and displays the corresponding pattern. The next example shows how multicolored zip LEDs can be controlled by an analog voltage input. As the voltage is increased, the rainbow pattern scrolls faster and faster. Now to control some traffic lights. The default color is green, but when the button gets pressed, the program works through a sequence of 3 more instructions for red and yellow. This program has an instruction for checking the analog voltage input and setting the motor speed according to how big the voltage is. The other 3 instructions also check the analog voltage input and light up a different color LED accordingly: red for high speed, yellow for medium speed, green for slow. This example begins by showing a happy face, but it changes to a frightened face when a loud noise is detected by the microphone. The input sensor here uses ultrasonic waves to measure the distance to a near object. This is the sort of system used by cars as a parking aid. When the object gets too close, an alarm sounds. The closer the object, the faster the beeps. Here's another example using the rainbow LEDs. This time the program counts how many times the button is pressed. The number of LEDs lighting up increases for each press. Now a stopwatch program. You press button A to start the clock, and a different LED lights up as each second passes. You press the other button to stop the clock, and the elapsed time shows on the microbit LEDs. We have now used all the sensors and output devices on the Labbit board. In the Mr. Bit coding editor, the simulation view allows you to select the ones you want to use in your program. Here are the inputs, and now the outputs. Switching to the system view, we can see all the corresponding blocks. To switch on and make the outputs work, we add the control modules and create the program scripts. There are tutorial videos showing how to create program scripts for all the examples. Check these out on the Mr. Bit website or the Insight Resources channel.